Hello viewers, welcome to my channel Learn Electrical Engineering 121 Pod. Hello viewers, in last session we have solved the problem regarding signal flow graph. We'll go for one more problem, and this is the system we have chosen, and for this we are supposed to find out overall gain. That is given by 1 by delta sigma pk delta k. To start with, we'll find out the number of forward paths, that is given by k. I have already drawn the forward paths and found out the gain. This is only to reduce the video length. Here the number of forward paths obtained are 6. Let's see what those are. Path 1, P1, we can clearly observe here it's from 1 to 2, 2 to 3, 3 to 4, 4 to 5 and 5 to 6. So here this one. Product of the gains for this total path, that is 1 into G2 into G4 into G6 into 1. So P1 is obtained. For the second path, that is from 1 to 2, 2 to 7, 7 to 8, 8 to 5 and 5 to 6. Now here from 1 to 2, 1 into G3 into G5 into G7 into 1. It is nothing but G3, G5, G7. For the next part, 1 to 2, 2 to 3, 3 to 8, 8 to 5 and 5 to 6. So I have drawn here. So 1 into G2 into G1 into G7 into 1. That is nothing but G1, G2, G7. The next path is P4. 1 to 2, 2 to 7, 7 to 4, 4 to 5 and 5 to 6. So 1 into G3 into G8 into G6 into 1. That is nothing but G3, G8, G6. Then the next part, 1 to 2, 2 to 7, 7 to 4, 4 to 3, because in the same direction 3, 3 to 8, 8 to 5 and 5 to 6. Okay, this is the graph. So 1 into G3 into G8 into minus H1 into G1 into G7 into 1. That will give us minus G1, G3, G7, G8, H1. The next path is P6. 1 to 2 and 2 to 3 and 3 to 8. Okay, this is 8 and 7. 8, 8, 8 to 7 and 7 back to 4 and 4 to 5 and 5 to 6. So 1 into G2 into G1 into G8 into minus H2 into G6 into 1. That will give us this one. So how do we know the count of this path? That is simply by trial and error. You have to cross check all the ways so that you can find out number of forward path. Now we'll see individual loop gains. 3 loops here from 7 to 8, crossing 8 only once, again back to 7, this one. From 3 to 4 and 4 crossing only once, again back to 3. So one more loop. And from 3 to 8, 8 to 7, crossing 8 only once, again 7 only once, again to 4, again back to 3. So this is one more loop. So here P11 would be minus G4 into H1. The second one would be G5 into minus H2. Here this one would G1 into minus H2 into G8 into minus H1. So minus 1 becomes plus here. So I've got 3 individual loops. We'll find out the non-touching loops. Gain products of 2 non-touching loops. Now if you pick these 3 individual loops, we pick this and this, you have 3 and 4 common. So these two won't be the non-touching loops. Now if you pick this and this, 7 and 8 are in again common. So definitely this won't be the combination for 2 non-touching loops. when you pick these two, definitely you don't have anything in common. So this is one combination of two non-touching loops. That is nothing but 3 4 G4 minus H1 7 to 8. This is G5 and minus H2. Gain products of two non-touching loops. You have only one combination here. Two non-touching loops and only one combination you have. That is nothing but P11 into P21. P11 into P21 minus G4 H1 into minus G5 H2. That would be G4 G5 H1 H2. Now we have got the individual loop gains and also the forward path gains. Now we'll go for calculating delta. Delta equal to 1 minus sum of individual loop gains, that is nothing but P11 plus P21 plus P31 plus sum of all possible combinations of gain products of two non-touching loops. That would be P12 1 minus G4 H1 minus G5 H2 plus G1 G8 H1 H2 plus G4 G5 H1 H2 give us 1 plus G4 H1 plus G5 H2 minus G1 G8 H1 H2 plus G4 G5 H1 H2. The next task is to find out delta K. That is the case, you have to cross check all the forward paths and find out whether there is any possibility that you have a part of the graph which is not touching kth forward path. Delta say equal to, if you can observe, from 7 to 8, it's G5 minus H2. So this is the part which is not touching the first forward path. 1 minus sum of individual loop gains, that is nothing but this one, P21. 1 minus of G5 H2, then we've got 1 plus G5 H2. Second path will have delta 2. G4 and minus H1. So this is the part of the graph which is not touching the second forward path. 1 minus P11, that is nothing but 1 minus G4 H1, 1 plus G4 H1. No non-touching parts for the other paths, say 3, 4, 5 and 6. For that reason, delta 3 would be 1. Delta 3 or delta 4 or delta 5, left with only 1. Now we'll apply Mason's gain formula and find the overall transfer function. Overall gain equal to 1 by delta sigma pk delta k. 1 by delta a count is 6, so P1 delta 1 plus P2 delta 2 plus P3 delta 3 plus P4 delta 4 plus P5 delta 5 plus P6 delta 6. We'll substitute all the calculated data and out the transfer function. So delta would be 1 plus G4 H1 plus G5 H2 minus G1 G8 H1 H2 plus G4 G5 H1 H2. P1 is G2 G4 G6 into delta 1 is nothing but 1 plus G5 H2 plus P2 is nothing but G3 G5 G7 into 1 plus G4 H1 plus G1 G2 G7. Delta 3 is anyhow 1. Then P4 G3 G6 G8 into delta 4 is 1 is minus G1 G3 G7 G8 H1. P6 would be minus G1 G2 G6 G8 H2 into delta 6 is nothing but 1. Overall gain for the particular chosen system. If you do have any queries, please mention in the comment box below.
Thank you for watching. If you find this video helpful, please like, share and subscribe. Stay tuned for more videos.